Hi, this deck of cards to facilitate working through the MCAT-style passage, functions of the basilar membrane. And of course, the content deals in the biological foundations of behavior. The proximal part of the basilar membrane is sensitive to high or low frequency sounds. So is the proximal part of the basilar membrane more receptive to high or low frequencies? That would be high. And here we can see the proximal part vibrating to high frequency sounds. All right. By the time the energy gets down here, it dissipates. So the proximal part is the most proximal part is receptive to frequencies of 16,000 hertz and 8,000 hertz and 4,000 hertz, and the degradations decrease as you go further into the distal location. Okay. The distal part of the basilar membrane is sensitive to high or low frequency sounds. So by now, I'm sure you know the answer. What is it? That would be low. So here you can see low frequency waves propagating all the way to the distal end of the basilar membrane. And as you travel further down the basilar membrane, the degradation of frequency reception keeps on decreasing. So at the lower end, you can see that you're receptive to 500 hertz, and a little bit more proximal, 1000 hertz, and so forth. So the distal end is more receptive to low frequency. The C blank is a fluid-filled structure containing the organ of corti. So what snail-like looking structure is fluid-filled and contains the organ of corti? I'll give you a moment. That would be the cochlea. Here we see it right here. Okay. And the proximal part is the vestibular membrane. We can see it's a snail-like structure. The middle is the malleus. Here goes the organ of corti. Outside it is the scala vestibuli. Okay. And it contains perilymph. And here we see the perilymph and the scala vestibuli. And here goes the scala media, which contains the organ of corti, our part of interest. And the fluid here is endolymph. It's a little bit different from the surrounding perilymph. Okay. The blank membrane, or the eardrum, is connected to the oval window via the malleus, incus, and stapes. So what's an AKA for the eardrum? I'll give you a moment to think. That would be the tympanic membrane. So here goes the tympanic membrane or eardrum, connected to the malleus, the incus, and the stapes. And here it goes on a revolution, so you can see a full perspective of what it looks like. The blank is the fleshy, visible part of the outer ear. So what do we call the part of the ear that we can see? Some people have really big ones, some people have really tiny ones. What is it? That would be the pinna, okay? The fleshy outer part. And the pinna actually is designed in a way to conduct sound. It determines, the range of sound we can hear, and the curvature actually determines how the sound waves enter our ear. Okay? The oval window connects the stapes to the C blank. So the oval window connects the stapes bone to what? Here we see that it's the cochlea. And here goes the stapes. And beneath it is the oval window. So the stapes, okay, or the stirrup, tapping on the oval window. This is the oval window region, the entryway to the cochlea. And here goes the moment of truth, the tapping on the oval window. It's like asking them to open the door almost.